Everyone, and welcome to yet another problem from LeetCode. Here we are going to see valid anagram. So here we are provided two strings s and t, and we need to check whether it's anagram or not. If yes, we return true, else false. Well, the question arises, what is anagram? So you know the very well line from your very favorite Harry Potter series is I am Tom Riddleston. I am Tom Marlborough Riddle, and the anagram for this is I am Lord Voldemort. Sorry, I messed it up. So this is an anagram of this. It means the way you arrange letters within a string of string 1 and string 2. The total content of the letter doesn't changes. So I appears once, here too I appear one, D appear twice, D appear twice over here, and so on. Likewise, if you know anagram, what anagram is, the logic is pretty much clear. So how would we solve this problem? So first of all, we can check that how many characters exist. So this is very naive approach. First of all, I'm discussing. Obviously, we are not going to settle up upon this. So approach 1. So within this approach, obviously we will be discussing upon how many characters we have in string 1, we have in string 1 and 2. So for A, I'll check yes, they have 1 and 1, then it's very well, and so on. For B, for C, D, up till Z. You see the problem with this approach is for every characters there are 26 characters, and for every character we are my bad. There are 26 characters, and for every character we are going and comparing that we are iterating string 1 and string 2. So this is not very well approach. So 26 into n number of times iteration plus n number of times in string 2 iterations, and obviously simultaneously we are maintaining the count. So what about the approach 2? Instead of going from A to Z all the strings, can't we go just from like within our string we have A as first character, how many times A occurs in our string and how many times A occur in this string. Well, you have reduced number of counts from 26 to limited to your string, but overall it still remains. So check within string still remains O of n. Approach 3 can be very simple, that let's have a mapping. Now this approach 3 can be a combination of approach 1 and 2. How this will work? So for now, think that we have an anagram string. So this is our string. So if we found from left to right we are iterating, and if we found A, I'll mention that hey, A is occurring once, N is occurring once, and next time if A occurs I will say A is occurring twice. Likewise I'll go G, which is occurring once, R, A, and M occurring once. And this we have developed a frequency map. So this frequency map, once I combine with T, the another string, I'll check out that hey, whether everything is working or not, whether every characters are satisfied or not. If yes, then I'm good to go and say that hey, these are anagrams of each other. So obviously I'll go ahead and say that it is character, or I'll just say int of frequency, or for short form I'll just say frequency is equal to new int of 26, because we are not going beyond 26 characters, as it is all over lowercase English letters, and we are not going to change this frequency. So let's stick to this one. So int, or I'll just say character ch within s.to char array for I'm having a character ch, I need to convert it into the appropriate index. So appropriate index is equal to ch minus a, because every character has its own ASCII code and the smallest ASCII code is a, so minusing it with a results in appropriate index. Once I have appropriate index, I'll just go ahead with the index and increase its counter. So this is how we populated the map. Populate map, and here we will be going to reduce count. What do I mean by reduce count? So if a is occurring once over here and a, so I'm reducing 1 to 0, and if I have n is encounters and next element is a, so I'll go ahead, reduce one count and make it as 2. So likewise I'll go ahead and take one by one character ch from here as well, but this time t, 2 character array, and obviously we are going to check for appropriate index. Index is equal to ch minus a, and frequency, but this time for that index I'm going to decrease the value. Once I have the frequency checked, I need to return. So shall I return directly? No, not exactly. I cannot return directly, because think for a while whether if t is not just this number but t contains a lot, a b c d e f, so rest of the characters would go into the negative value irrespective of any countings. So I need to check for each and every element within count within the frequency table. If count is not equal to 0, then return false, as this is not an anagram, which means within, if I cut down Lord, it means that I am Voldemort is being satisfied from the Tom Riddleston, because every character is being matched with that, but the reverse cannot be true. But anagrams obviously violates the definition of it. So return false when it's not equal to 0, but once we find out everything contains 0, so return true. Let's submit this one and check for the test cases whether it's passing, and yeah, it has passed all the test cases, and we see that it is running in the O of n time complexity and O of 1 technically space complexity, because we are limited to 26 characters only. So this was all about it. This is very good problem of hashing. This is very beginner problem of hashing indeed. So for more such hashing related problems, click the video on your right, and I'll see you in the next one.